Okay, this is question 6 on the 2019 additional maths paper from WJC. And this is one of the good old do not use a calculator questions. So you have to make sure you show all you're working with this so it's clear that you haven't used the calculator. Okay, you can use your calculator every step of the way to check your answers. There's no stopping you doing that, but they want to see you doing everything. So let's start with 2 over 6 plus root 3. And you want to write it in the form where the denominator is an integer. So A, B, C, and D. So it's going to be something like 5 plus 3 root 2 over 6. Something like that, where they're all whole numbers. So what we're going to do, in order to make the denominator rational, so to get rid of that square root, I'm going to multiply by 1. Now, the one I'm going to use is going to be a special version of 1 called the conjugate. And the conjugate means I'm going to multiply top and bottom by 6 minus root 3. So you see the connection with the bottom? All I've done is I've changed the sign. And as long as I multiply the bottom by 6 minus root 3, then I'm multiplying and dividing by 6. So 6 root minus root 3 over 6 minus root 3 is something over itself, which is 1. So I'm multiplying by 1. Now what this does, it means that I can okay, so with to expand the top, because I've got 1 term multiplied by 2 terms, I've gone by a 1 by 2 grid. So I'm going to put my 2 on the one side, my 6 minus root 3 on the top, and then I'm going to start multiplying. So the area of this one box is going to be 2 times 6, which is 12. And then for this box, it's 2 times negative root 3, so that's negative 2 root 3. So that's the numerator sorted out, 12 minus 2 root 3. Notice now it's in A plus B root C. So A is 12, B is negative 2, C is 3, all integers. Okay, to find D, I need to expand the bottom. Now the bottom is a 2. And we are going to put the left-hand side being 6 plus root 3, and the top being 6 minus root 3. And then we're going to start multiplying to work out the value. So this one comes from 6 times 6, which is 36. The next one is 6 times negative root 3 to go there, so negative 6 root 3. Then for this one, it's 6 times positive root 3, so plus 6 root 3, and then root 3 multiplied by negative root 3 is going to give me an overall negative 3. So we end up with 36 take away 3. These are our normal integers. 36 take away 3 is 33. And then my square root part, I've actually got 6 root 3 minus 6 root 3, so they're going to cancel. And that's why we multiply by the conjugate, because it will always cancel. So this 33 can actually go there, and that's our final solution. Just making sure that there's no common factors in, so that would be as simple as possible. Okay, so part B is an indices question where you have to simplify each of the expressions. Now, the key thing to look for in these questions is here on the numerator, we've got a multiplication. So in this, we've got multiply and we have a divide. And if we have that, we could use the Indices Laws, which tells us that when we multiply things that have the same base, and they have the same base, they've all got a base of y. When we multiply, we can add the powers, and when we divide, we can take them away. So this then becomes y to the power of, so when we multiply these two together, because they've got the same base of y, we can add the powers. So it's negative 3/5 plus 4/5. Then we're going to divide by y to the 3/4. Again, same base. So now we can subtract that power. So subtract 3/4. So if we want to show all our work, we need to make sure now that we get a common denominator, and the lowest common multiple of 5 and 4 would be 20. So this would be, if I want this to be 20, I'm going to multiply top and bottom by 4. So that's negative 12 over 20. Plus, I'm going to multiply top and bottom on this one by 4. Again, to get 16 out of 20. And then I'm going to multiply negative 3/4 by 5 over 5, which is negative 15 over 20. And now it's a case of just doing this adding up. So negative 12 plus 16 is 4. Minus 15 is negative 11. So it's y to the negative 11 20ths. Okay, part B. Different setup to the question. Here, it's an addition on the top, not a multiplication. So when it's an addition, you can only add two terms together if they're the same type of term. So you may think, oh, well, they've got the same base of the same type of term. They're an x term, but they're not. In the same way, you can't add an x squared to an x to make one overall term. It's not going to be x cubed. It's not 2x squared, because they're not both x squared terms. So same thing with these. So even though they're both sevenths on the top, one of them is a 2x to the 2/7 term, the other is an x to the 3/7 term. So we're adding, we can't do that. So what we end up doing is we can split this fraction. So we can treat this as an addition of two fractions. This should be x to the 2/7 over 2x to the 2/7 plus 6x to the 3/7 over 2x to the 2/7. So we can write those two separately. So x to the 2/7 divided by 2x to the 2/7 plus 6x to the 3/7 over 2x to the 2/7. Now, if you're not sure what I've done, just look at what we would do in reverse. If we had this question, when we have the same denominator, all we would do is add the tops together. So we'd end up with x to the 2/7 plus 6x to the 3/7, and they'd be all over the 2x to the 7, which is that we had there. So all I've done is I've done like a reverse step. That was a case of simplifying, because now I've broken it down to this one. We have a division. And when we divide, we can subtract the powers if they come from the same base, which they do. They both have the same base of x. So with the numbers, we got 1 over 2. We can't do anything with that, so I'm going to leave that as 1 over 2. But x to the 2/7 divided by x to the 2/7, well, you've got something divided by itself, haven't you? And that something divided by itself will then cancel out. So actually, this whole fraction just simplifies down to a half. Plus, okay, if I deal with the number part first, I got 6 over 2, which is 3. And then x to the 3/7 divided by x to the 2/7, we're going to do a subtraction. So 3/7 take away 2/7 is 1/7. So overall, this becomes 3x to the 1/7, and then that can't be simplified any further.